Hello, Riverside. Today's lecture is on the endocrine system. So we're going to jump to sharing the screen, which for some reason likes to be challenging sometimes. Here we go. Um, Here's the screen. Boom. Um, so endocrine system. We said at the beginning of the year that all things have to respond to stimuli. You can respond. We have two response systems, one that's slow and long lasting. It's the endocrine system, and one that's short or fast but short lived. That's the nervous system. Um, Before we get into this, we should touch upon. Oh, so this is the glands and hormones unit. We should touch upon feedback. Oh, I guess if I'm going to follow the format of the website, I'll go do these terms first, and then we'll get to feedback. Since this is glands and hormones, we're going to learn about glands, hormones, and target tissues. A gland is a group of specialized cells that produces a substance called a hormone that has an effect elsewhere in the body. A hormone is a substance produced in a gland, released into the blood, and travels around the body and affects a different part of the body. There's a lot of these that we're going to learn about. And then there's the target tissue. The target tissue is the tissue that hormone can target, and it's based on whether it can get into that tissue. And then we should touch upon feedback loops. A feedback loop is where something detects its own presence and then either makes more of itself or stops making it. A negative feedback loop is one that detects its presence and says, oh, there's already some here, and stops. A negative feedback loop is, or sorry, a positive feedback loop is one that detects its presence and then makes more of it. Or it just makes more of the same. So with a negative feedback loop, if it didn't detect it, then it would make it. If it did detect it, then it would stop making it. So it changes it. It makes the opposite happen. Positive feedback loop, if it sense it, then it would continue to not make it. If it did sense it, it would continue to make more. So our body's always running these negative feedback loops that sort of regulate us. I'll describe it better in class. Here are some of the glands we're going to learn about: the pituitary, the pineal, the thyroid, the adrenal, the pancreas, and the gonads. Gonads would be the testes or ovaries. The pituitary is the master gland. As you can see, it's located in the brain, right about there in the brain. And it's called the master gland because it makes a lot of glands, like a lot of hormones. I mean, it makes a lot of hormones, and some of those hormones control other glands. So that's one of the reasons we call it a master gland. It turns out there's another gland that controls it, but whatever. Some of its hormones that we're going to learn about: growth hormone that causes growth if it gets into the cells. Making too much and you'd grow a lot. You'd have what's called giantism, you'd not make enough, and you'd have what's called dwarfism. Or you could make it but not let it into the cells, and then that's a form of a growth issue. Thyroid stimulating hormone stimulates the thyroid, which is a different gland, to do its job. So it regulates the metabolism is what it does. Too much, and you digest your food very quickly and you have a lot of energy. Too slow, and you don't digest your food and you put on weight. You're always tired. Adrenocorticotropic hormone, big long name. It just means that it stimulates the adrenal gland to make adrenaline. Too much, and you might be like always have adrenaline in your body, so you're very nervous and jittery. Too little, and you would need to do death-defying things in order to get any stimulation from the adrenal gland. So you'd be like a adrenaline junkie. Vasopressin regulates water retention. And so too much and you retain a lot of water and you swell up like a sausage. Too little and you pee out all your water and you get very dehydrated. Oxytocin, for years and years and years, it was thought to just have to do with uterine contraction and milk secretion. So primarily things that if you have ovaries and mammary glands, it would affect. Turns out it also causes warm, fuzzy, cooperative feelings. Luteinizing hormone regulates sex hormones. Follicle stimulating hormone regulates production of sperm and eggs. Prolactin makes the mammary glands make milk. So it makes lots and lots of hormones, as you can see, and many of them have major impacts like growth or controlling other hormones. I have to go through these quickly. I know it's lightning fast here. You can pause and replay, but if I don't, I can't post it. The thyroid gland regulates your metabolism. It makes a bunch of hormones, thyroxine, parathormone. We don't need to know them, calcitonin. You don't need to know the hormones it makes. It makes a whole bunch of hormones, and they regulate the metabolism. The adrenal gland makes adrenaline. Also, that's its English term, adrenaline, and I should say American term, adrenaline and noradrenaline. In England, they would call it epinephrine and norepinephrine. So an EpiPen is just epinephrine. It's just adrenaline. The pancreas makes glucagon and insulin. Both regulate sugar metabolism, how quickly and easily you break down sugar. If you don't make insulin, you would be type 1 diabetic. If you make insulin but your body doesn't recognize it, you'd be type 2 diabetic. And then you have your gonads. They make testosterone, estrogen, or progesterone. So testes make testosterone, ovaries make estrogen and progesterone. Testes and estrogen are very similar. Actually, they convert back and forth, but they do the primary sex characteristics, readying the sperm and eggs. But they also do some secondary sex characteristics. If you think about the difference between like a boy and a man, or a girl and a woman, you can see the secondary sex characteristics. So deepening voice, broadening shoulders, body hair, those sorts of things, or developing breasts, widening hips, body hair, those sorts of things. The pineal gland, I know, has a name that a lot of people giggle at, but it makes melatonin, which regulates your circadian rhythms, your daily cycles, your sleepiness, when you need to go to the bathroom, when you get hungry, those sorts of things. We'll talk about the circadian rhythms in class. I don't have time to right now, but that's melatonin, and that is a lot of glands and a lot of hormones and a lot of memorization. And I apologize because I know memorization can be challenging. Part of this year is learning how to take good notes and learning how to study. So this is one of those units that will really put you to the test for that. So I'm going to sign off here, and let me know if you want anything in more depth. And if not, I'll see you in the next one, the nervous system.